Hello, Mr. Worst here. I'm going to try to make this, okay, it's not going to get bigger. All right, you're going to do a retake, so I'm going to go over how to do the test from before. So hopefully this will help you do your retake. So here in the Unit 3 acceleration test, this is a master copy. You had a distance time graph. Okay, so one of your questions was, distance time graph, identify the type of motion. Options were constant velocity, stopped, accelerating, speeding up, or accelerating, slowing down. The slope on a distance time graph is the velocity. So our slope here is constant. It's not changing. So for every unit of time, every 2 boxes of time, it looks like we go up a little bit more than 1 box here. That's bad. Okay, so basically the slope stays the same. Okay, it's not curving, it's straight. That means we have constant velocity there. If it was stopped, a stopped line would be flat because the distance is not changing over time. It's the same over time. If it was speeding up, it would be curved upward. If it was slowing down, it would be curved downward. There's a lot of lines on there, and I can't undo them. Can I get rid of them? I can erase them. Ooh, that's going to be messy. Oh, it's not going to go away. Will they clear? I don't like this. Okay, anyways, so that is distance time graph. Okay, so speeding up should curve up. Slowing down should curve down. It does curve down if it's slowing down. And if it's constant velocity, it's an angled line. Okay, this is positive velocity here because the line's going up. That means we're increasing in distance. Over time, we're moving away from the reference. The reference is this bottom line down here. And yeah, okay, let's move on to the next question. I got this floating. Can I just delete that box? I can't delete that box. Okay. Down here, distance time graph. Ooh, this one's curving up. It's speeding up because for every unit of time, our velocity is increasing. I want to draw that on here, okay? So velocity is the slope of the line. So here at the beginning, we have a low slope. Here in the middle, we have a medium slope. And here at the end, we have a high slope. So you can see the velocity is increasing. That's called accelerating, speeding up. That's a speeding up, the acceleration, or yeah, the velocity is getting steeper, higher, because for every unit time, the distance is, the change in distance is getting bigger. Okay. And I did it to myself again. I got to delete all these by hand. Grr. I need better tools. Whenever teachers in teacher meetings are like, oh, we're going to teach you a tool. I'm all right. I'm like, oh, really? I'm going to get a new screwdriver? Yeah, when somebody gives you a tool, it should be like, oh, yes, I got this Sawzall. No, okay. All right, so next question. Identify the type of motion for this graph. So here, we are in the negative velocity area. Okay, so negative. This line here in the middle is zero velocity. That means if something is on that line, it is stopped. It's not moving. So we go from like high negative to low negative. So we're moving towards stop. So we're going from, all these graphs go from the velocity time, they go from fast, if it's out here on the edge, or fast up here at the top, faster, and then closer to the line. So if we go from fast to stopped, closer to the line is slower. Slower, that's what I'm writing right now, if you can read that. Look at that bad handwriting. Okay, so I'm going to go from fast to slow. So if I'm going from fast to slow, that means I am slowing down. Yeah, I'm slowing down. Okay, my recording's going to end in 24 seconds. Let's see if we can do one more. Down here, which of the following velocity time graphs represents acceleration, slowing down? Oh, it's this one. That one's slowing down. This one's also slowing down. Oh, but it also asks us moving back towards the start. Bad, my bad. I'll talk about that in the next video.